This video demonstrates how to use instance segmentation models in Mech-Vision for object recognition and localization. Currently, Mech-Vision supports two methods for importing deep learning model packages. The first method is through the Deep Learning Model Package Inference step. For detailed instructions, refer to the introductory video on instance segmentation model training. The second method uses the Assist Recognition with Deep Learning feature within the 3D Target Object Recognition step. The second method is generally recommended. It allows to combine deep learning-assisted segmentation with 3D matching. This makes project configuration more efficient. Therefore, this video will focus on this approach. The main workflow includes importing the deep learning model package, setting the 2D ROI, setting the confidence threshold, and adjusting the dilation parameter. Now, let's begin the operation. Open Mech-Vision. Click Config Wizard in the 3D Target Object Recognition step. Enter the process of target object selection and recognition. Enable the parameter setting of Assist Recognition with Deep Learning. Import the trained model package. Select the package here. Next, set the 2D ROI to improve recognition accuracy. Note that the ROI here defaults to the same region defined during training in Mech-DLK. If the workpiece falls outside the ROI, slightly adjust the ROI. However, if the adjusted ROI differs significantly from the training ROI, it may affect model performance. In that case, please redefine a proper ROI during training. Here, the default ROI is appropriate. Then, set the confidence threshold. Switch the visualization view to Deep Learning Result. Click Configure Inference. Based on the confidence values of the deep learning output, set the confidence threshold for instance segmentation. This threshold should be set at a proper level to filter out low confidence and poorly segmented results. As shown in the current image, when the threshold is around 0.3 to 0.4, many masks are missing and recognition is poor. At around 0.6, the masks are more complete. Thus, accordingly adjust the confidence threshold. In this case, it is set to 0.45. After this, run the step to check the result. In addition, configure the dilation parameter. This is to ensure the deep learning model outputs complete mask information at the image edges, thereby obtaining more complete object point cloud. Switch back to recognition result to better check the point cloud. The current edge point clouds are complete, thus no adjustment is needed. With that, the deep learning model package configuration is complete. This function can be used in combination with other settings to support object recognition. If the recognition result is still not ideal, start by checking the image quality. If the image is blurry, or the edges are not clear, the image brightness and color balancer step can be used to adjust contrast. This step enhances brightness and color balance, making edge detection and object recognition easier. It can be seen that the current input and output images show a clear difference. However, if the image quality is acceptable and the recognition is still poor, model iteration is required. Use the incorrectly recognized images as additional training data, retrain the model, and apply the updated model again. This concludes the workflow for applying instance segmentation models. You can also refer to our documentation for more details about applying instance segmentation models.